And now I'm going to demonstrate the operating principle of the 4-stroke cycle engine. And it is called 4-stroke because it takes a 4-stroke of the piston to complete the process needed to convert the energy in the fuel into work. So this is the diagram of the 4-stroke cycle engine. The first stroke is suction or induction. The crankshaft is rotating clockwise and the piston is moving down the cylinder. The inlet valve is open and a fresh charge of air is being drawn or pushed into the cylinder by the turbocharger during the first event or the suction stroke. The piston moves downward, pulled by the connecting rod to the lower end of moved by the crank. The piston moving away from the cylinder head creates vacuum in the cylinder and outside air is drawn or sucked into the cylinder through the intake valve that opens about the beginning of the suction stroke and stay open until the piston reach the bottom dead center. And the next stroke is compression. The inlet valve was closed and the charge of air is being compressed by the piston as it moves up the cylinder. Because energy is being transferred in the air, its pressure and temperature increase by the time the piston is approaching to the top of the cylinder. The pressure is over 100 bar and the temperature is over 500 degrees. During the third stroke, it is called power stroke. The hot gases push the piston downward. This is effective stroke of the engine. The gas expand from the increasing volume and through the connecting rod and crank transmit the developed energy to rotating crankshaft. Shortly before the piston reach the bottom dead center, exhaust valve opens and the products of the combustion begins to escape through exhaust ports to the outside. And the fourth stroke is the exhaust stroke. As the piston approaches to the bottom of the cylinder, the exhaust valve starts to open. As the piston now moves up the cylinder, the hot gases are expelled from the cylinder. As seen in a 4-stroke, required 2 revolutions of the crankshaft. Those in a 4-stroke, 1 power is obtained for every 2 crankshaft revolution.